Okay. Yesterday we saw the repetition and college, and repetition causes the shuffle, and shuffle is the most expensive in Spark. Now let's understand why shuffle become expensive. Because internally shuffle cause because internally shuffle cause disk IO, network transfer, serialization, deserialization, memory pressure, and temporary shuffle files, task, recreation, and stage recreation. And all these operations internally, when happened, all these operations are expensive. So when shuffle happen, these are the things internally happen. That's why shuffle is the most expensive things. Now let's understand. We all already saw that network transfer disk IO. Now today we will saw that we will see serialization. So let's understand the serialization. Suppose executors want to send raw data, but Spark cannot directly send Python object through network. So first, Spark convert raw data into binary format. Like if there is raw data, so first Spark convert this into binary format, and then it will send to the executor through network. Suppose this is a executor. So first it will convert into binary format by Spark, and then that binary format data sent to the exe executor through network. So this happen internally when a serialization happen. And this is the serialization. And then a receiving executor if now raw data converted into binary format and sent to the executor. Now, if sometimes again executor wants to convert binary data back into objects, and that become deserialization. Like if this executor again convert to binary to object. And this is called the
ऑब्जेक्ट माने हमर जो स्टैंडर्ड फॉर्मेट जो डाटा था जेମିତି
हाँ आमे जो पाइथन फॉर्मेट रे ताको
हम्म
सेट
हम्म।
करछे पाइथन ऑब्जेक्ट
अच्छा लिस्ट वगैरह सब रे जो था
हाँ फास्ट से रो डाटा को आमे एतले सेंड करूचे से इंटरनली कन्वर्ट करे बाइनरी फॉर्मेट को तापरे
बुझली
एग्जीक्यूटर सेंड करियो तापरे एग्जीक्यूटर पुणी कन्वर्ट
आउ
करियो
थरे
बाइनरी ऑब्जेक्ट को
उल्टा तारा
यस तो सेटा होची serialization and deserialization and both uses CPU memory and time and sometime due to shuffle it crash the executor because shuffle is the most expensive things we know but it is the most dangerous things also so sometimes due to shuffle it crash the executor. Now let's understand why shuffle can crash executor. Why shuffle crashes the executor. Now in real time suppose we have suppose one task receive 500 GB of shuffle data means there are so many partitions. So in that partition, suppose after shuffle, it will again create the shuffle partition, and from that partition, suppose one shuffle data is 500 GB of data. Now executor memory becomes full. Right? If we have 500 GB of shuffle data and other data like suppose after shuffle there are 2 GB data of shuffle data and another is suppose 5 GB of shuffle data. So these are three partitions after shuffle right. This will be become the three partitions. So one of them is 500 GB of shuffle data. So now this 500 GB of shuffle data execute received by one executor. Like this. Suppose this is executor one, and inside that there is task one, and this executor memory is suppose 100 GB. Now there is another two executor. Suppose there are three executor and this 500 GB of data is received by executor one and this 2 GB of data is received by executor two and inside this there is task two. And this 5 GB of data received by this executor 3 and inside that there is task 3. So now what happened? It received 500 GB of data, shuffle data, but the memory size is 100 GB. So first it load 100 GB of memory data. 100 GB of memory means 100 GB of data from that 500 GB of data. Then it again spill to disk. Like suppose this is our disk and this disk size is 200 GB. So now what happened? First, it load 100 GB of data into executor, and then it again this write that data from 500 GB of data, write 200 GB of data into this, but still it has 300 GB of data. Sorry, 200 GB of data, because 100 GB and 200 GB will 300 GB, but still it has 200 GB of data. And in this situation, the executor is crash. Like now, this will crash. And suppose now executor memory becomes insufficient. Then what happened? Massive disk spill happens, GC pressure increases, executor slow down, and sometimes executor crashes also. And this is very common in production issue. Now let's connect this to skew. Suppose after shuffle, partition 0, which is this one, partition 0 has 500 GB of data, and partition 1 has 200 GB, 2 GB of data, and partition 3 is 5 GB of data. Now, one shuffle read task become extremely heavy. That one task means this task, suppose what happened, this task run very long, and it consume huge memory, and it also spills huge data, and also slow down entire stage. This one task will run very long and consume huge memory and spill huge data, and also slow down entire stages. Meanwhile, other executor become ideal. So in this scenario, this is called the skewed shuffle. It's called the skewed shuffle. And this is one of the biggest spat optimization problem. Now let's see by taking an example. We already saw that in yesterday class. Let's see. Info. So in this scenario, first of all, what will be the DAC? Inside DAC, it will be the like the whole stage, code gen, and then exchange, then whole stage, code gen. Means first it create one stage, then after that it will exchange, and exchange means shuffle is happening, and then another stage. This is the internal process. Before exchange, now understand this properly. Before exchange, old partition processing, and in exchange, shuffle write, shuffle files, data redistribution, and in after exchange, that is shuffle read and new partition creation and next stage processing. So internally, this flow is happening. Right? In so internally, that flow like in stage one, stage 1, it read old partitions and process rows and shuffle right. This will happen in stage 1. Then after that, exchange happen. Then in stage 2, it will shuffle read, build new partitions, then process shuffle data. This will happen internally. First, in stage 1, it will read the old partitions and process rows, then shuffle right, then exchange happen inside exchange. Then after exchange, in stage 2, it is shuffle read and build new partitions and process shuffle data. So this will happen internally. This is actually SPAC shuffle architecture. Now, very important production concept, like what is shuffle files? During shuffle, SPAC creates temporary files like index files, data files, shuffle blocks. So this is like all files. So during shuffle, internally, SPAC creates temporary files like index files, then data files, then shuffle blocks. And if job are huge, thousands of shuffle files get created. That is why disk management, executor storage, field tuning become important in production SPAC cluster. Because if it will create 1,000 or 5,000, 10,000 of uh, shuffle files, that will cause the issue, and also it is dangerous, and it also crashes the executor. Now let's understand actual shuffle internals properly using a real SPAC example where we use a group by and aggregation functions. So let's take this data. Suppose this is a data frame, and we uh, perform a transformation like df dot group by country dot count dot show. So let's sum this. Now, as soon as SPAC sees group by country, like this pattern, when we write df dot group by on country column, when as soon as SPAC sees this group by dot group by on country column, SPAC understand like all India row means it has data like the ID name and country column, and in country there are India, USA, and UK value. So it will understand, Spark internally understand all India rows must come together, and also all USA rows must come together, and also all UK rows must come together. That means data must move across executor, and after shuffle, it will create three shuffle partitions because according to the department column, and there are three unique value in department, so it will create three shuffle partitions. So like when this happen internally, the count when we write group by country dot count, it will first trigger the shuffle, like this. Then after shuffle, it will create three partition file, three shuffle partition file. Like partition 0 has India data, and partition 1 has the USA data, and partition 2 has the UK data, like this. And these happen first of all because the data is like, because the data is like this. So when we write like group by on country dot count, it will first trigger the shuffle, and after shuffle, it will create three partition file. Partition 0 has the India data, and partition 1 has the USA data, and partition 2 has the UK data. This is the shuffle partition after shuffling. Now this movement is the shuffle. Now in real time, let's connect to the this in real time. Now suppose in real time, Spark cluster has five executor. Like there are executor 0, suppose, and executor 1, and executor 2, and executor 3, and executor 4. Suppose in real time there are five executor. Now what happened? And Spark created five partitions from this data internally. Suppose Spark created five partitions, like this is partition 1, sorry, partition 0, suppose this is partition 0, and these partition 0 contain first three rows of data. In second partition, like it has suppose two rows of data. Then in partition 2, suppose it has another two rows of data. In partition 3, suppose it has another two rows of data. and in partition 4 it is last rows of data. Suppose internally it create 5 partition file, and as we know, one partition equal to one task. So suppose tasks are distributed like executor 0, inside executor 0 it will create the map task 0, right? Map task 0 0, and these tasks will read partition 0, and again executor 1 will create the map task 1, and this will read the partition 1 data. Then executor 2 also create 1 map task 2, and this will create read the partition 2 data. And executor 3 will create the map task 3, and this will read the partition 3 data. Now partition 4 will create map task 4, and it will read the partition 4 data. So internally, suppose in real time, this will happen. There are 5 partitions file and there are 5 executors. So Spark will create 5 tasks, and each task will read each partition file, one partition file. Now inside that, what happened means after this, the shuffle will happen because all the rows are present inside different partitions. Like if we want when we group by country and then count, so what will happen? It will first uh, arrange all the India rows together, and then it will count all the India rows. Like inside partition 0 there are 2 India rows, and inside partition 1 there is 1 India rows, and in 2 there is 1 India rows. So it will arrange first all the India rows together. So inside, suppose let's see inside what happened. Executor 0 internal. Executor 0 and map as 0. So suppose this is the executor 0. Let's say we are seeing on executor 0 only, and that same process will happen in other executor. So let's see. First, what happened inside these? Suppose mapped as 0 process the Rahul, Aman, and Priya data, which is the India, USA, and India data, like this. Now, Spark starts shuffle, and suppose Spark decide reduce partition 0 is will contain the India data, and reduce partition 1 contain the USA data, and reduce partition 2 will contain the UK data. Now, inside map task 0, Spark groups rows country wise. So internally, what happened? It will create the blocks like this. Suppose this is India block, and inside that it has Rahul data, and inside that it has Priya data. What? Like this. It will first create the India block, and then it will create another block, USA block, and inside USA it will arrange the Oman and another UK block. But in partition 0, there is no UK file. So this will be the empty. Now inside map task 0, it will create 3 block, and these block are called the shuffle block. This block is called the shuffle blocks. And these are not a physical file. This is just a block. And all things are created temporarily. These are the shuffle blocks. And this is the data, actual data inside the executor 0. Now, what happened? So internally, India rows has the India block has the Rahul and Priya, USA block has the Oman, and UK blocks is empty because inside partition 0 there is only India and USA data. So it will create 3 blocks, and these group logically chunks are called the shuffle blocks. And very important thing is shuffle block is not a physical file. It is just grouped data for one reduced partition. Now, Spark must temporarily store this group data on disk because till now these are only blocks. So we need to, Spark need to store those blocks into temporarily store in this group data on disk. So map as 0 creates one physical file. Like suppose the physical file is shuffle 00.data. This file is mapped as will create this file inside the executor. Mm, This file will create it. And what happened inside this? Now this shuffle 00.data is a actual physical file, and inside this file it will like India block and USA block and UK block. And inside one data file, there are multiple blocks because currently we have only three category, department three category, India category, USA category, UK category. But in real time, there are so many type of categories. So according to that, inside one data file, inside one data file, there are multiple blocks exist, and it does not store in text rows because we see all these things are in text. So but internally when it creates the shuffle 00 data, it will not store those data into text rows. It will store in the byte because what in a disk or memory, what the things are stored, that will store in a byte. So what happened? Like if we see inside these, this is inside this data. Now, if you can, if you want to see what exactly inside shuffle data means how it's stored. Suppose this is shuffle data inside shuffle 00 data, and inside that first it will store rows into serialized binary data, and those binary data are look like 1010, like the binary in binary format. It will store like in this format. So suppose this India block, this India block occupy suppose 120 byte 120 bytes in the disk, and the USA block occupy 60 bytes, and this UK block, because it has no data, so it will occupy 0 bytes. So internally inside the support 00.data, it has stored the rows into serialized binary data, and each block occupy some bytes of data inside that disk. And now uh, inside something conceptually like 1010, it is stored like this type of byte, because files on disk are stored in bytes, not rows. Now suppose India blocks occupies 120 bytes and USA block occupies 60 bytes. Then internally data file looks conceptually like byte 0 to 120 equal to India block, and byte 120 to 180 equal to USA block, and byte 180 to 180 equal to UK block. So this is very important. Byte does not mean rows. It means physical position inside binary file. Now another executor later may suppose another executor come out. Suppose executor 1. Now executor 1 may ask like give me only India rows. Suppose it will ask executor 1 that I want only India rows. So Spark cannot scan whole data file every time, because inside executor 0 it has India block, USA block, UK block. So when executor 1 asks for the India block file only, India file, then it will not scan all the blocks. So for that purpose, it again create another file called shuffle 00 dot index file. And this file stores locations like India block as byte 0 to 120, and USA block has occupy the bytes from 120 to 180, and UK block occupy the byte from 180 to 180. So
ହେଲେ ଏଠି index 0 1 2 ଏମିତି ନ ହେଇକିରି byte ରେ ଏମିତି index ଟା ରହିବ।
ହଁ ମାନେ ବାଇଟ୍ ମାନେ କଣ, ଯେମିତି କି ଆମର ଏଇ ଯୋଉ 1010
ହଁ
ଫାଇଲଟା ଷ୍ଟୋର ହେଲା,
memory ହଁ
ବାସ୍ ମେମୋରିର ସେଟା ଗୋଟେ ତାର
ହୁଁ,
ଲେନ୍ଥଟା
ହଁ
କହନ୍ତି।
ହଁ
ତ ସେଇଠି ସେ
ହୁଁ
এইটা ହିଁ ଷ୍ଟୋର କରୁଛି। ତ ଯେତେବେଳେ executor 1 means it will ask like I want only India data, so it will
ହୁଁ
check first the
ସେ ସ୍କାନ
index
କରିବ
file.
0 ରୁ 120 ଯୋଉ ବାଇଟ୍ ଟା କୋଉଟା ଅଛି।
Yes, first it will check the index file, then it will see the byte 0 to 120 India, then it will directly go to that block of data. So then it will give the India data to the executor file. Sorry,
ଅଲଗା ଆଉ ସ୍କାନ
executor 1.
କରିବାକୁ ପଡିବନି, ଏତିକିରେ ହେଇଯିବ।
Yes, so it will not scan all the data, because if we scan all the data, it will also means occupy the means it will take the more resources, more
CPU
network. Yes, so due to that, it will first check the index file, then it will go to the data file. Now, Spark directly jumps to the correct byte position. Now, very important thing is map test 0 was running on executor 0. So this whole process was done by map text 0 inside the executor 0. So shuffle 00.data and shuffle 00.index are stored on executor local disk. And similarly, inside all executor like executor 1, executor 2, there will be it means executor 1, it will create map test 1, and map test 1 it will create the shuffle 0 1 data and 0 one index like this. Mm, okay. Suppose this is executor 0, and inside this set executor 0, it has this. This is called 001 dot data, and it has also the index file. Now, as like this, other executor have like inside executor 1, it has created, it will created the shuffle 01 dot data, and inside India block, it has the data like Neha, and inside USA block, it is empty, and inside UK block, it has John data, and index file also 01. 2, this is executor 1, this is 2, this is 2, and inside this, it has Rohit data, and inside this block, it has Big data, and inside this, it has empty data, and an executor 3, 3, index file 3, done. Let's the 4, empty, and this is also, let's go. So inside all executor, it will create the files like this. You can see like inside executor 1, it has the India block, USA block, and UK block, and according to the partitions, it will create those blocks, because initially we saw partition 0 has the these three data, partition 1 has the these data, and according to these data inside each executor, it will create that block and put those rows into that block, and also uh, it will create the shuffle 00 data file and shuffle 00 index file, and this is same in all the executor. Now what happened after all these, like till now the map as 0 is running, and those all things happened by the mapped as 0, and after that inside executor 0 the reduced as 0 has started, because in map task it perform the transformations, like it process the data, read the data, and after all that the reduced as 0 has started, which will collect the data. So reduced as 0, suppose reduced as 0 handles all the India data, handles all the India rows. So it will ask, means reduced as 0 will ask all the executor for the India rows. Like it will first inside the executor 0, it will first fetch the India rows, and from the executor 1 it will fetch the India rows, and again from executor 2 it will fetch the India rows, from executor 3, then from executor 4. Then so what happened, reduced as 0 will ask all the executor India rows. Suppose from executor 0 it will get the India block data, and from executor 1 it will get also the India block data, like this, and from executor 2 it will also get the India block data, and executor 3 it will also get the India block data, and in executor 4 it will also get the India block data, like this. Now see, now executor 0 has all the India block data after shuffling. Now it will easy to group by and perform the count on those data. Now it has all the India data inside one executor. Now it will perform the group by and then count the data. Now after that, and this part also called the shuffle read. And after that, it will calculate those all data and show the result as India count equal to 5. Because in our code we write like this, group by country dot count. So when we write like this, we see like this is a means simple one, like simple one line code, but internally this whole things happens. Inside each executor it will create a task, and that task will first shuffle, means create the shuffle blocks. Those are not physical file. It will create the blocks according to the department category. Then it will create to store those blocks into actual data. It will create a actual physical file, shuffle 00.data file, and inside that it will not store as text rows. It will store as the serialized binary data, like all India block, USA block, and UK block will store in the byte data, and the byte format is like 1010, something like that. And
ଏ ସବୁ ଯାକ ଏକ୍ଜିକ୍ୟୁଟର ମେମୋରିରେ ଏକା ଚାଲିବ ନା?
ହଁ, ସବୁ ଜିନିଷ ଏକ୍ଜିକ୍ୟୁଟର ମେମୋରିରେ ଚାଲିବ। ତାପରେ
ଓକେ,
କଲେକ୍ଟ ହେଇକି ସବୁ ଏକ୍ଜିକ୍ୟୁଟର ରେଜଲ୍ଟ କଲେକ୍ଟ ହେଇକି ସେ ଡ୍ରାଇଭର ମେମୋରିକୁ ଯିବ, ଦେନ୍
ଡ୍ରାଇଭରକୁ ଦେଖ
ଦ
ପଠେଇବ।
ରେଜଲ୍ଟ ୱିଲ୍ ଶୋ। ତ
ଡ୍ରାଇଭର ତାପରେ କଣ ରିସୋର୍ସ ମ୍ୟାନେଜରକୁ ପଠେଇବ ନା କଣ?
ହଁ ନାଇଁ ଡ୍ରାଇଭର ତାପରେ ଆଉଟପୁଟରେ ସେଇଟା ଶୋ କରିବ।
ଶୋ କରିବ ଅଛି।
So imagine when we call this single line, what happen inside those all executor. This is a big process and this is very fast also. So now, and as like this, suppose reducer task 0 fetches all India blocks from executor 0 and India block from the executor 1, India block from the executor 2, executor 3 and executor 4 like this. This fetching is called the shuffle read, and this is why shuffle becomes very expensive, because this whole things will happen internally when shuffle is happening, because spat now does during this process, spat now does disk so network transfer and disk reads and deserialization and data merge and also aggregation. So finally, in all India rows come together, like the rows like Rahul, Priya, Neha, Rohit, and Anjan, and then aggregation happen. Then it will show the India count equal to 5. Now let's connect this with Spark UI actually. What happened inside actually Spark UI? It will like whole stage code gen, then exchange, then whole stage code gen. Internally, this will happen when a shuffle is happen. This is the whole process. Now, very important thing is exchange represents shuffle boundary. In this exchange, it represents the shuffle boundary. And before exchange, it has it did like the old partition processing and map tasks running, shuffle write happening, and also shuffle files getting created. And after exchange, shuffle read starts, reduce task starts, and also new partitions created, and then aggregation happen. So internally, the flow become like in stage one, there's like read partitions and process rows and create shuffle blocks. Then write shuffle data and write index files. Then exchange happen. Then in stage 2, it will shuffle read and page shuffle blocks and build new partitions. Then perform the aggregation. Then it shows the final output. So this will happen when we write the group by operations. This will happen for. Now, this whole process we did in this data, because this is a much less data. But in actual real time, there is so big size of data, like 500 GB or 1 TB of data. So according to that, it will create huge production job, and each job like create 1,000 plus map tasks, and that task will create thousand plus data files plus 1,000 plus index files. Index file. This is why shuffle become disk heavy because there are so many file created. So if the disk size is very less, then it will cause the disk heavy and also the network heavy and also the memory heavy. And that's why one of the most expensive operation in Spark is the shuffle. Now, another very important concept is sort-based shuffle. Basically, in modern Spark, usually use the sort shuffle, meaning before writing shuffle data, Spark first sorts record internally. Suppose like this internally, when it creates the blocks, it will first sort those data. Then because fetching becomes efficient and partition grouping become easier and merge operations become faster. So internally, Spark often did like first read rows, then sort rows, then create shuffle buckets, then write shuffle files. So internally, it did like this. Now, final most important thing is why means it is like interview question. Why Spark engineers fear shuffle? Because it is expensive things and also because of shuffle. Because it directly affect on the performance, memory, disk uses, and network uses, and also the execution time. It will affect the execution time and also affect the executor stability, and also it will affect the cluster scalability. So that's why most data engineer fear the shuffle. So most Spark optimization technique are basically reducing shuffle because in every maximum every operation the shuffle is happen. So most Spark optimization technique are basically reduce to for the reducing shuffle. That is why good Spark engineer try to reduce unnecessary repetition, avoid unnecessary group by, and optimize joins and reduce skew also, and tune shuffle partitions and balance partition size. That's the whole things. Now let's see the other aggregation functions, like we see the count functions first, and it shows like this. It will show the India count 5, USA 3, and UK 3. Now let's see other aggregation functions, and each for all the aggregation function, the internal things happen like this. This whole process will happen internally when we use a aggregation, group by and aggregation. So other aggregation like df dot group by country dot I think some will not working this. So basically there are other aggregations like
ଏଇ ଗ୍ରୁପ ବାଇ ତ ଯେମିତି ବି ମାନେ କରିବାକୁ ପଡିବ ହିଁ ତ ମାନେ ଡେ ଟୁ ଡେ ଲାଇଫ ରେ।
ହଁ ଡେ ଟୁ ଡେ ଲାଇଫରେ ସେଇଟା ପାଇଁ ତ
ହୁଁ
ମାନେ ଇମ୍ପୋର୍ଟାଣ୍ଟ ସେଇଟା, କାହିଁକି ନା ଦିସ୍ ଆର୍ ୟୁଜ୍ ଫର୍ ଦ ରିପୋର୍ଟିଂ, ଡ୍ୟାଶବୋର୍ଡସ୍,
ହୁଁ ହୁଁ।
ବିଜନେସ୍ ମେଟ୍ରିସେସ୍, ଇଟିଏଲ୍ ପାଇପଲାଇନ୍ସ, ଏନାଲିଟିକ୍ସ, ଆଣ୍ଡ these are the
ତ
actual
ଏଇଟା
things happen in
ସଫଲ
real time.
ଏକ୍ସଚେଞ୍ଜ ବହୁତ କରିବାକୁ ପଡିବ ତ ସେଇଟା କେମିତି ମ୍ୟାନେଜ କରିବେ ହେଲେ
ମ୍ୟାନେଜ ମାନେ
ଏଭଏଡ ମାନେ।
ଅପ୍ଟିମାଇଜେସନ ଯେମିତି ରହିଲା ଏଠି କେମିତି କି ଆମେ ଯେମିତି ଫାଷ୍ଟ ରିପାର୍ଟିସନ ୟୁଜ କରିବା ଟୁ ରିଡ୍ୟୁସ ଦ ପାର୍ଟିସନ କାଉଣ୍ଟ
ଆଚ୍ଛା
ବିକଜ
ତାପରେ
ଇଫ ଦେयर ଆର୍
ବ୍ରଡକାଷ୍ଟ ଜଏନ ଇନ ସବୁ କଣ କଣ ଯୋଉ
ବାସ୍,
କରୁଥିଲ।
ତ ସେ ଅପ୍ଟିମାଇଜେସନ ଦେଖିବା ଏ ସବୁ ସରିଲା ପରେ
ହୁଁ
ପରଫର୍ମାନ୍ସ
ହୁଁ
ଅପ୍ଟିମାଇଜେସନ ଅଛି ତାକୁ ଦେଖିବା ଆମେ।
ହୁଁ ହୁଁ।
There are means basically there are a lot of things inside SaaS, like a ocean. If you
ହୁଁ ହୁଁ ହୁଁ।
means enter it will like
ସଫଲ କରିବାକୁ ପଡିବ ବଟ୍ ସଫଳ କେମିତି ଅପ୍ଟିମାଇଜ କରିକିରି ରିଡ୍ୟୁସ କରିବ ସେଇଟା
bus.
ଦେଖିବ ନାଇଁ।
Yes, means shuffle any cost happen, it will happen. We cannot avoid that, but we
ହୁଁ
can
ହୁଁ ହୁଁ
optimize that. That is the
ହୁଁ
main
ହୁଁ।
process. So aggregation. So we saw the count, and like that, other aggregation functions like sum and average, and also mean, max. These are the most used aggregation function in real life, and these are used for the reporting, dashboard, used for the reporting, dashboard, business matrices, and also analytics. But internally, group by is not simple. We write one line of code like group by dot count dot so this one line. But internally, group by is not simple because Spark must regroup similar keys, move rows, aggregate row records, and create final output. And internally, this is deeply connected with the support. Now let's test all these things by taking a data like which data. Now suppose we write like df dot group by department dot sum of salary dot so and these are most the interview questions like if interviewer asks like show the total salary for the each department, then we can write like this, and it will show the department wise sum of salary like this. For IT department, the total salary, the HR department, total salary, and finance department, total salary. Now, this loop very simple, but internally, Spark does huge processing because Spark must bring same department rows together, calculate totals, and create aggregated output. Now, means it will happen like here we created the partitions like this. Suppose this has this partition, 5 partition. So as like these internally, it will also create for the this data also. Now another function like sum. Suppose okay sum. Then another is average. Suppose this is the average, and another function like mean and the max. See. See, for sum, it will show like this. Total sum of all salary according to department wise, then department wise average salary, then department wise minimum salary, then divided by max ln. So these are the most used aggregation functions. Now let's see. Now let's understand another important internal architecture, because when we perform a aggregation, SPAC does not directly perform final aggregation immediately, because we saw that uh, in when we call a aggregation, this whole thing happen inside, but internally it also has some internal aggregation. Like internally it performs SPAC uses first partial aggregation, then local aggregation, then final aggregation. So let's see what actually it is. Suppose partitions are like partition 1 is contain the IT, which is the 50,000, and partition 2 suppose partition 5 contain the IT of 60,000. So now before shuffle, SPAC first tries local aggregation inside each partition. So suppose inside partition 1 there is one row IT 50,000, but suppose basically in real life there is so many rows. So suppose another rows like IT 40,000 inside partition 1, and inside partition 5 there is 60,000. So internally what happened? So internally what happened? Inside partition 1, first it will perform the partial aggregation. Like instead of sending every individual row, like it will not send those individual row to the another executor. First, it will perform the aggregation inside that executor first. First, it will calculate total IT like 50,000. Suppose we perform the sum function aggregation, then it will perform internally, and it will send this result to the other executor. And this is the partial aggregation. Now, why SPAC does this? Because shuffle is expensive and also shuffle is very optimized. So if SPAC directly shuffle all rows, network movement increases and shuffle files also increases, and also memory pressure increases. So SPAC first reduce data locally. This is the optimization is very important. Means now after partial aggregation, they will perform the local aggregation. So SPAC, then after that, it will perform the final aggregation. So this whole process is happened when we perform an aggregation to reduce the, means to optimize the file. Just a minute. Hello. हाँ अबे क्लास रे अछि टिके रह परे फोन करछु हाँ so when it perform the partial and local aggregation, now all the IT total must come together first on each partitions first. Now the DAG internally shows like it will first scan the data, then perform the partial aggregation, then exchange happen, then the final aggregation. So internally this happen. and this is the very important DAG pattern. Now let's understand this step by step. In scan, it will first spark read partitions. When it in the scan step, it will first read partition. And in step 2, in partial aggregation, inside each partition, Spark performs local aggregation.
କେନ୍ ମାନେ
Some
ଏ ଯୋଉ ଯେତିକି ଜିନିଷ ଅଛି ସବୁଜା ପାର୍ଟିସନ ରେ ଗୋଟେ ଥରରେ ଚାଲୁଛି ନା?
କୋଉଟା
ସ୍କେନ୍ ମାନେ ସବୁ ପାର୍ଟିସନ ରେ ସ୍କେନ୍ ଚାଲିବ।
ହଁ ନାଇଁ ଏଟା ସ୍କାନଟା ଇଚ୍ ପାର୍ଟିସନ ପାଇଁ ଡିଫରେଣ୍ଟ ହବ ମାନେ ଫାର୍ଷ୍ଟ ଦିସ୍ ଇଜ
ହଁ
ଫର୍
ହଁ ହଁ
ପାର୍ଟିସନ
ମାନେ
1
ହଁ ହଁ
ହଁ
ତାପରେ ପାର୍ସିଆଲ ଏଗ୍ରିଗେସନ ମଧ୍ୟ ସେମିତି ସବୁ ପାର୍ଟିସନ ରେ ଗୋଟେ ହେଇ
ବାସ୍
ହେଇଯିବ।
ପାର୍ସିଆଲ ଏଗ୍ରିଗେସନ
ତାପରେ
ହବ
ସେଇଟା
ସେଇଟା ସେଣ୍ଡ
ତାପରେ
ହବ
ମିଶିବ ସବୁ।
ଅଦର ଏକ୍ଜିକ୍ୟୁଟରକୁ ତାପରେ
ହୁଁ
ଅଦର
ହୁଁ
ଏକ୍ଜିକ୍ୟୁଟର ମାନେ ଏଠି ଯୋଉ ଆମର ହେଲା ଫାର୍ଷ୍ଟ ହେଲା ମ୍ୟାପ୍ ଟାସ୍କ ଦେନ୍ reduce
ହୁଁ
task then this reduce task will collect all those aggregated data and it will perform the final aggregation then it shows the final result
ହୁଁ
that
ହୁଁ ହୁଁ
happen internally then in partial aggregation it perform the local aggregation something like
ଲୋକାଲ ଏଗ୍ରିଗେସନ ମଧ୍ୟ ସ୍ପାର୍କ ଇନବିଲ୍ଟ ତାର ସିଏ କରେ
ହଁ
ଇଣ୍ଟରନାଲ ସେଟା।
ସେଇଟା internally ସବୁ ଏଟା ହଉଛି ଏଇ ପାର୍ଟଟା
ହୁଁ ହୁଁ। ମାନେ ଅଧିକ ଡାଟା କମ ପାଇଁ ସଫଳ ହବ ବୋଲି ଗୋଟେ ଥରରେ ସେ ସେଠି
ବାସ୍
କରିଦିଏନି।
ହଁ ସେଇଟା ହଉଛି ଅପ୍ଟିମାଇଜେସନ ଯୋଉଟା କି ଇଣ୍ଟରନାଲି ଅପ୍ଟିମାଇଜେସନ ରହେ ତା ବାଦ ଆମକୁ ବି କିଛି ଅପ୍ଟିମାଇଜେସନ କରିବାକୁ ପଡେ ଯେମିତି କି ପାର୍ଟିସନ ଫାଇଲ କମେଇବା ରିପାର୍ଟିସନ୍ସ ସେଇଟା ଇଣ୍ଟରନାଲି
ହୁଁ
ସେ
ହୁଁ ହୁଁ
ପ୍ରାୟ
ହୁଁ।
ଟାଇମ ହ୍ୟାଣ୍ଡେଲ କରେନି so ସେଇଟା ଆମକୁ ମାନୁଆଲି କରିବାକୁ ପଡେ ତ ଆହୁରି ବହୁତ ସାରା
ଆଚ୍ଛା
ଅଛି ଆଗକୁ ଦେଖିବା ଆମେ
ହୁଁ
ସଲ୍ଟିଂ
ହୁଁ
ଅଛି ଇଏ ଆଉ
ହଁ
କେଚିଂ ବି
ହଁ
ଅଛି ତ ସେ ସବୁ ଅପ୍ଟିମାଇଜେସନ ଦେଖିବା ନାଉ
ଓକେ।
ଇନ୍ ନେକ୍ସଟ ଷ୍ଟେପ in exchange now it will start the shuffle starts in this part actual shuffle starts. Now it bring the same department partition total together and this become the shuffle aggregation. This become the shuffle aggregation because aggregation now depends on shuffle data. Now in final stage, what happened? Spark merges partial totals. Something like suppose for IT, it has total like this much and in another also it is it has IT like 60,000 then it will show the total this will happen internally this will happen now understand why this is efficient without partial aggregation all rows suffered huge network movement but with partial aggregation only partial total suffered much smaller shuffle size and this is huge optimization internally only. Now let's connect to these stages. Before exchange, local aggregation happens and after exchange, final aggregation happens. So exchange again becomes stage boundary. Now internally, the execution becomes like in stage 1, it will read partitions, then just a minute. Hello? Uncle, ticket ହେଇଗଲା କି?
हेलो
ହଁ ଟିକେଟ
हाँ
ହେଇଗଲା ହଁ ହଁ ଠିକ ଅଛି
वो बोले अरेंजमेंट
ହଁ ହଁ
ठीक है
ହଁ ରେ ସେ କଣ ମନା ଟିକେଟ ହେଲାନି କଣ ଆଜି ମୁଁ କଣ କରିପାରିବି ମୁଁ କାହିଁକି ଆଗରୁ କରିକି ଦଉଥିଲେ ସେଥିପାଇଁ ଦିଆ Now in stage 1, it will read partitions, then local aggregation, then partial aggregation, then shuffle right. And after that, exchange happen. Then in stage 2, it will like shuffle read and final aggregate and then generate out. This will happen internally. This is the actual aggregation internally. Now, one important production concept is, suppose one department has 5 million rows, while other have the thousand of rows. Like here, IT department contain the 500 million rows, and other department like HR contain the 1000 rows. Now, after shuffle, one partition become huge because it has the 5 million rows. This is huge. And one task becomes very slow. Again, the skew problem. Again, this will become the skew problem. So, aggregation job can also suffer from skew and memory pressure and disk fill and slow tags. Now, let's see the group by final. When you perform a group by, this is the final one. Group by aggregation internals. What happened internally? It is like we read partitions, local aggregation, partial aggregation, shuffle, exchange, aggregate, then final output. This will happen internally when we call a group by. Now, next is yes, now let's understand the data skew. Sorting. Now let's understand the data skew and sorting. Suppose we have this data. Suppose we have this data and we create a data frame like by creating the department column and salary column. Now distribution is like IT has 7 rows, and HR has 1 rows, and finance has the 2 rows. Now, when we run the aggregation like df dot group by on department, not sum of salary dot so. Now, SPAC will shuffle rows, bring same department rows together. Internally, something like partition 0 as partition 0 as all IT rows, and partition 1 has the all HR rows, and partition 2 has the all the finance rows. Now, one partition become huge. This partition is huge. Now, one task also becomes huge, and for that, one executor becomes overlaid, and that is skew. Now, for to reduce this skew problem, we will use the sorting. Now, let's understand what is meant by sorting. Sorting is like a artificially splitting large keys. Instead of keeping one IT key, we will create like IT0, IT1, IT2, and IT3. Like this is a artificially splitting large keys. Instead of keeping only one IT rows, we will create like IT0, IT1, and IT2, and so on, like this. Now, all IT rows will not go into same partitions. This distributes load. Now, let's see in actual code. See, first we perform the, we create the salt column, like salted df equal to df dot with column, and the column name is salt. Then we create a random number, random multiply by 4. Now, this will create a salt values, like random salt values. Let's see. And this is one of the most interview question, like optimization using the salting. So this step we apply. This is the step 1. It will create a salt column where it include the random value. Like we use the random function from this pyspark.sql.function import. I use the import stack. So it will use random function from that method. Now it will create the sort column with random value. Then in step 2,
random भाई चारटा कौन ପାଇଁ ନେଲ ଚାରି ସାଇଡ ଯୋଉ ଲେଖିଲ
এটা ମାନେ ମଲ୍ଟିପ୍ଲାଏ କରିବା ପାଇଁ ଯୋଉ ଗୋଟେ ରାଉଣ୍ଡ କରିବା ପାଇଁ ଏଟାକୁ, ଯେମିତି କି ଯୋଉ ଫ୍ଲୋର ଆମେ ନେଇଛେ ନା ଏଟା,
ହୁଁ
ତ ଯେତେବେଳେ ରାଣ୍ଡମ ରେ ଗୋଟେ 4 ମଲ୍ଟିପ୍ଲାଏ ସେ ଗୋଟେ ପଏଣ୍ଟ ଆସିବ।
ହେଲେ 0 1 2 3 ଯାଏଁ ଦବ ସିଏ
ହଁ
ନା କଣ
ମାନେ
ସେଟା ତ
ହଁ ସେଇଟା ମାନେ ରାଣ୍ଡମ ଇନଟୁ ମଲ୍ଟିପ୍ଲାଏ 4 କଲେ ସେଟା 0 ଟୁ ମାନେ 3 ଯାଏଁ ଆସିବ। ମାନେ କଣ
ହଁ ହଁ
ଯୋଉଟା ଲାଷ୍ଟ ଭ୍ୟାଲୁ ହଉଥିଲା n ମାଇନସ 1 ଯାଏଁ ଆସିବ ସେଟା। ସପୋଜ ଏଠି ଆମେ 5 ନେଇକି ଦେଖିବା,
ବୁଝିଲି
ତ ସେଟା ସେ
4 ଯାଏଁ ଆସିବ
ବାସ୍ 4 ଯାଏଁ ଆସିବ। ଆଉ
ହୁଁ
ଫ୍ଲୋର
ହୁଁ
ନିଆଯାଇଛି ଏଥିପାଇଁ ସେଟା ଗୋଟେ ୟୁନିକ୍ ନମ୍ବର ଆସିବ, ଯେମିତି କି ପଏଣ୍ଟ ଡେସିମାଲ ଆସିବନି ଆଉ।
ମୁଁ ବୁଝିଲି ଫ୍ଲୋର ମାନେ ପୁରା ତଳଟା ସିଲିଂ ଟା ଯୋଉ ଉପରଟା ପୁରା ଯୋଉ
ହଁ
ହେଲେ ଏଇଠି କେତେ ଫ୍ଲୋର ଯୋଉ ନିଆହଉଛି
ହୁଁ।
ରାଣ୍ଡମ ପରେ କେତେ ଆକ୍ଚୁଆଲି ମାନେ ନିଆଯାଏ ସେଇଟା କଣ ମାନେ ଡିପାର୍ଟମେଣ୍ଟ ୱାଇଜ ଦେଖିକି ନିଆହବ ନା କଣ
ହଁ, ସେଟା
ତମର ଯୋଉ ସେତେବେଳେ
according to data first means first we will check the data frame, how many type of data frame are there. Like first we
ହୁଁ
perform
ହୁଁ
the group by, then it will show
ହୁଁ
the
ହୁଁ
total department categories. Then according to that we will take that random value. So that leave this
ଓକେ
1 to 4. Now take. Now in next step we will create the salted key. Salted key. First step the salt column, and in next step we'll create the salted key like salted df equal to salted df dot with column, and the column name is salted department. Now in salted department we will perform a concat on department, and then we will add a underscore, then the salt column. So now what it will happen, it will concat the department value, like department suppose finance, then it is like finance underscore the salt value, any random salt value, suppose the salt value 1, it will create the 1. So it will create like this department, then salted df dot so let's see. Now it will create the salted department. Now we have in IT department, we have not only IT keys only. It has so many different keys like IT3 keys and IT1 keys and IT4 keys, IT0 keys. Now when the partition is created, then it will create according to the key. Like it will create a IT3 key and it will put this rows and this rows. So now it will create so many partitions, and according to that when we perform an aggregation, then it will create that much of tasks. So it will not create one huge task for the IT department, it will create so many small stacks for the IT department. Now the data queue is
ହେଲେ
complete.
ଏବେ ପାର୍ଟିସନ ଟା ଆମର ଯୋଉ ସଲ୍ଟିଂ ର ଲାଷ୍ଟ ନମ୍ବର ହିସାବରେ ଏବେ ପାର୍ଟିସନ ଟା ରହିବ ନା କଣ
ବାସ୍
ମାନେ
ସଲ୍ଟେଡ୍
ଟିକେ ଇଭେନଲି
ଡିପାର୍ଟମେଣ୍ଟ
ଡିଷ୍ଟ୍ରିବ୍ୟୁଟ
ହିସାବରେ
ହବ
ହଁ ଏଇଟା ଇଭେନଲି ଡିଷ୍ଟ୍ରିବ୍ୟୁଟ ହେଇଯିବ, କାହିଁକି ନା ଆଗରୁ କଣ
ହୁଁ
ହଉଥିଲା ଆଇଟି ଡିପାର୍ଟମେଣ୍ଟ 7ଟା ଥିଲା ତ ଗୋଟେ
ହୁଁ
ପାର୍ଟିସନ
ହୁଁ
7ଟା ରୋ ରହୁଥିଲା, ବଟ୍ ଏବେ କଣ ହବ ଆଇଟି
ଏବେ
3 ରେ ଦିଟା
ଆଇଟି
ରହିବ।
ଥ୍ରୀ ଆଇଟି ଥ୍ରୀ ଗୋଟେ
ବାସ୍
ହୁଁ
ଏଇଟା ହେଇଗଲେ ଯେତେବେଳେ
ଫୋର
ପୁଣି
ଫୋର ଗୋଟେ
ଟାସ୍କ କ୍ରିଏଟ୍ ହବ, ତ ଆକର୍ଡିଂ ଟୁ ଦିସ୍ ଇଟ୍ ୱିଲ୍ କ୍ରିଏଟ୍ ଦ ଟାସ୍କ, ସୋ
ହୁଁ
ଇଟ୍ ୱିଲ୍ ନଟ୍ କ୍ରିଏଟ୍ ଏ ହ୍ୟୁଜ୍ ଟାସ୍କ,
ଆଉ ସ୍କିଉନେସ୍ ଟା କମିଯିବ
କମିଯିବ। Now IT rows split into multiple keys, and this is the most important idea. Now let's perform the final aggregation. Partial aggregation is sorted df dot group by on. Now we perform the aggregation on salted department, not the department column. Salted department. Then perform the aggregation like sum of 7 and so.
ଅଧିକ ପୁରା ଡାଟା ଥିଲେ ଏଇଟା ଜଣା ପଡିବ ଆକ୍ଚୁଆଲି ନାଇଁ ଟିକେ
ହଁ
କମ ଡାଟା
ଅଧିକା ଥିଲେ
ହେଇଯାଉଛି।
ଜଣା ପଡିବ। ଆଉ ଏଇଟା ଆକ୍ଚୁଆଲି ସ୍ପାର୍କ
ହୁଁ
ୟୁଆଇ ରେ ବି ଶୋ କରିବନି ଯେ କୋଉଠି ସଲ୍ଟିଂ ହେଲା। ଏଟା ଇଣ୍ଟରନାଲି ଆକ୍ଚୁଆଲି
ଆଚ୍ଛା ଆଚ୍ଛା
ହେଇଯିବ ତାର ସେ ମାନେ ପାର୍ଟିସନ
ଆଚ୍ଛା
ୱାଇଜ।
ଆଚ୍ଛା
ଆମର ଆମେ ଜାଣିଛେ
ହୁଁ
କଣ
ହୁଁ
ପାର୍ଟିସନ ଟା କି ୱାଇଜ କ୍ରିଏଟ ହୁଏ। ତ ଯେତେବେଳେ ସେମ କି
ହୁଁ
ହବ
ହୁଁ
ଗୋଟେ ପାର୍ଟିସନ କ୍ରିଏଟ ହବ। ତ ଆକର୍ଡିଂ ଟୁ ଦ୍ୟାଟ ଇଟ ୱିଲ କ୍ରିଏଟ ଦ୍ୟାଟ ମଚ୍ ଅଫ ପାର୍ଟିସନ୍ସ।
ଆଚ୍ଛା।
See, now it will shows the IT3 total salary, IT0 total salary, IT2 total salary. But till now, this is a problem because in actual real life, the business team required total IT department sum, not the IT3 sum, IT0 sum, IT2 sum. So we need to perform another final aggregation. Like final DF equal to partial aggregation dot with column with column create the department and split. We will split that column sorted department 2 because currently the department like IT underscore 3. So we split by underscore and only we take the 0 index because when it split, it will shows like IT and 3. So we will only take the 0 index, like it will take the only IT. Now then after that we perform the group by on department dot sum of sum of salary.
ଡିପାର୍ଟମେଣ୍ଟ ବୋଲି ୱିଥ କଲମ ରେ ଆଉ ଥରେ ନ୍ୟୁ କଲମ ଟି ଆଡ୍ କଲ ନା ଭାଇ ସେଠି?
Oh, the new with by youth with column when we write department means there is already a department column. So with
ନାଇଁ
column
ପାର୍ସିଆଲ ଏଗ୍ରିଗେସନ ରେ ତ ନାହିଁ ନା।
ମାନେ ଏଟା ସଲ୍ଟେଡ DF ରୁ ଆସିଛି ନା ତ ସେଇଥିରେ
ହଁ
ଅଲରେଡି
ହଁ
ଏଇ କଲମ ଟା ଅଛି
ହଁ
କ୍ରିଏଟ ହେଇଛି।
ସେଥିରେ ଅଛି। ହୁଁ
ବଟ୍
ହୁଁ
ତାପରେ ଯେତେବେଳେ ଆମେ ୱିଥ୍ କଲମ ପୁଣି ଲେଖିଲେ ଦେଖ ୱିଥ୍ କଲମ ର କାମ କଣ ୱିଥ୍ କଲମ ର ହଉଛି କାମ ଯଦି ଏଇ ସେମ୍
ନୂଆ
ନେମ୍ ରେ
କଲମ କ୍ରିଏଟ
କଲମ
କରିଦିବ ନଥିଲେ ଯୋଉଟା ସେମ୍ ଥିବ ତାକୁ ରିପ୍ଲେସ
ବାସ୍
କରିଦବ।
ସେଟା ରିପ୍ଲେସ ତ ନାହିଁ ତାକୁ ଅପଡେଟ କରିଦବ
ହୁଁ ହୁଁ ହୁଁ
ଯାହା ବି
ହୁଁ
ତାର ଭ୍ୟାଲୁଟା ଅଛି। ତ ଏବେ ଏଇଠି
ଆଚ୍ଛା
ସେଇ ଆକ୍ଚୁଆଲି ୱାର୍କଟା ହେଲା ଡିପାର୍ଟମେଣ୍ଟ
ହୁଁ ହୁଁ
ଅଲରେଡି ଅଛି ତ ସେଇଠି ସେ ଅପଡେଟ କଲା ତାକୁ। ନାଉ
ହୁଁ ହୁଁ
ସ୍ପାର୍କ କମ୍ବାଇନ୍ସ salted partial result into final department total. Now it will shows the actual department wise sum of salary like for the IT department, for the HR department and for the finance department. Let's see. Step 3 application and this is the final execution. So in partial aggregation, it perform on salted department and in final aggregation, it perform on actual department. Now, this is the final result. Now, the internal flow like flow sorting is first original skewed data, then add salt column, then create sorted keys, then shuffle happens, then load distributed across partitions, then partial aggregation, then the final aggregation. So this is actually happen when we perform a sorting. Okay. And here the question is like why sorting works? Because SPAR has partitioning works on key value. Earlier, like it is perform the partition like on hash of only IT. Only IT. Earlier, always produce same partitions. But now using the sorted, it will perform the partition like IT on 0 and also IT on 1 and also IT on 3 like this. So now it produces the different partitions that distributes workload. Now in real production use, sorting is commonly used in skewed joins, skewed aggregations, huge customer data sets, and also sometimes transaction systems, and also in large event processing, especially when one key dominates datasets, where like this situation, suppose there are one key IT department, there are so many IT departments. So in that case, we use the sorting. For example, like the country India, we perform on aggregation, also on something like the status active and department IT and the product equal to mobile. Now, huge repeated keys create skew. So, final important understanding is without sorting one huge partition and one huge task and also the one executor overloaded. But with sorting, one large key is splitted and multiple smaller partitions created and multiple balanced tasks created, and that will be the better parallelism. And this is actually sorting optimization in SPY to overcome the skewness. Now let's see the window function. Okay, till now any doubt?
Okay.
Okay. Now let's see
କୋଡିଂ
the
ଇଜି ମାତ୍ର ଭିତରଟା ବୁଝିବାଟା ଟିକେ ମାଇଣ୍ଡ
ହଁ
ଲଗେଇବାର ଅଛି ନାଇଁ।
ସେଥିପାଇଁ ମୁଁ ପୁରା ଇଣ୍ଟରନାଲି ଦେଖିଲି ଟିକେ
ହୁଁ
ଟାଇମ ଟେକିଂ ହବ
ହୁଁ
ବଟ୍ ଆକ୍ଚୁଆଲ ଇଣ୍ଟରନାଲି ଏଇ ଜିନିଷ ଗୁଡା ହଉଛି ସବୁ।
ହୁଁ ବହୁତ ଡିପ୍ ତ ପଳଉଛି।
ଏଇଟା ଆକ୍ଚୁଆଲି ତମେ ଯେତେବେଳେ ପୁରା ରିଅଲ ଟାଇମ କାମ କରିବ ସେଠି ଜାଣିପାରିବ। ଏଇଠି ଆମର ଛୋଟ ଛୋଟ ଡାଟା ନା ସେଥିପାଇଁ ଜଣା ପଡୁନି ସବୁ ଜିନିଷ, କାହିଁକିନା ସ୍ପାର୍କ
ହଁ
କ୍ୟୁଆର
ହଁ
ସବୁ ଦେଖେଇବନି।
ହୁଁ
ଯେତେବେଳେ ହ୍ୟୁଜ ଡାଟା ହବ ଜିବି ଅଫ ଡାଟା
ୟୁଜ
ସେତେବେଳେ
ଡାଟା ଥିଲେ ସଲ୍ଟିଂ ଫଲ୍ଟିଂ ଏହା ସବୁ ପୁରା ଭଲସେ ଜଣା ପଡିବ
ବାସ୍
କେମିତି
ସେତେବେଳେ
କଣ
ଦେଖେଇବ
ହବ।
ଯେ
କଲାଠୁ ଜଣା ପଡିବ ବା।
କଣ କହିଲି?
ଗୋଟେ ପ୍ରୋଜେକ୍ଟ କଲେ ପୁରା
ହଁ
ବଢିଆ
ହଁ
ମାନେ
ବାସ୍ ୟା ପରେ
ପୁରା ବୁଝିବାକୁ
ନେକ୍ସଟ
ପଡିବ।
ସରିଲା ପରେ ଗୋଟେ ପ୍ରୋଜେକ୍ଟ ଆମେ କରିବା ଗୋଟେ ଯୋଉଟା କି ଆକ୍ଚୁଆଲ ରିଅଲ ଟାଇମ ଡାଟା ନେଇକି ଗୋଟେ ଜିବି ଅଫ ଡାଟା, କାହିଁକିନା ସେଇଟା ଆକ୍ଚୁଆଲି ଆମେ ଦେଖିପାରିବା ଯେ ଗୋଟେ ହ୍ୟୁଜ ଟାସ୍କ ଥିବ ଯୋଉଟା କି ଟେକ୍ ଟାଇମ ନଉଥିବ ବହୁତ ଟାଇମ, ତ ତାକୁ ସ୍ପ୍ଲିଟ୍ କେମିତି କରିବା, ଏ ଜିନିଷ ଆକ୍ଚୁଆଲି ରିଅଲ ଟାଇମ ଦେଖିପାରିବା।
ହୁଁ।
Okay, now the window functions. Now the question is why window function exist? Till now we already learned about the group by aggregation, shuffle, skew, also aggregation internals. Now we are entering one of the most important concept in Spark SQL, and this is mostly used in actual real life because after the final data load, we will use the window function to create those matrices, like in it is used like in heavily used like in the analytics, reporting, window function is heavily used like the heavily used in analytics, reporting, dashboards, and ranking system where you need then the financial calculations and also running totals, then time series processing. We'll see all example one by one. And internally, window functions are one of the most expensive operation in Spark because they involve shuffle, sorting, partitioning, row tracking, memory management. Because in normal aggregation, it also what happened? It will reduce the rows, only shows the final ledger. But in window function, it also need to track the row because we need to see the previous row, we need to see the future next row. So according to that, it will also track the row and also perform the total. So this is also the huge, means expensive operation than the aggregation also. So let's see. First, understand why window functions even exist. Because initially, people only had group by. Group by. But group by has one big limitation, like let's see using a actual data. See, suppose we have this data and we perform a aggregation on it. df dot group by on department, then the sum of salary dot so. So what will happen now? It will shows the output like output IT of total sum of salary, and it for HR it will shows the total sum of salary. Now here, okay, now it will shows the total IT department salary and the total HR department salary. But here original employee rows disappear. Only aggregated rows remain, meaning group by is collapses rows. Earlier we had like the Rahul, Priya, Aman and Neha. But after aggregation, we only have the IT and HR department, only grouped output remaining. Now suppose business requirement says, so each employee row, but also show total department salary. Means we need to show those all the employee record, and according to that, we also shows the total. So now group by cannot do this directly because group by removes original rows. This is exactly why window function exists. Now let's understand this carefully. Group by, what happened? It will many rows to one group row. Means the rows collapse. This from the group by. But window function which shows the original rows stay plus additional calculation column added. And in this, rows are reserved. This is the difference between a group by and a window function. Group by collapse the rows, but window function reserve the row and shows the total additional calculation column added. Now let's see the actual example. Suppose for this we will use, so to use window function, first we need to import the window, like from PySpark.sql.window, import window. This is the actual package. Now let's do a window function. And to use window function, first we need to define the window specification equal to window dot partition by on department. This is the window specification. We will see what is the work of actually partition by here. Now let's apply this. Result df equal to df dot which column. Now we create the department total, and here we use the sum of salary dot, we use the over keyword as like the SQL window specification. We pass the this window specification. We can pass this directly also here, but for the better code writing, we'll define this first, then pass this variable. Now let's see the result. Df dot show. Now see what happened. See, now look carefully. Original rows are reserved, still present, but additional calculation column also got added. This is the window aggregation, because in group by it collapses the rows and only shows the calculated total. But in window function, it show all the rows including the department total. Now this is the most important internal difference is group by. In group by, groups are means it is groups the rows and collapse rows and return the aggregated output. But in window function, it will groups related rows internally, perform calculation, but keeps original rows alive. This is why window functions are much heavier internally because Spark must preserve row relationship, track original rows, and calculate aggregation simultaneously. Window function are much heavier internally because Spark must internally preserve row relationships, then track original rows, then calculate aggregations simultaneously. Now, this is the very important production understanding is window function are usually more expensive than the group by because internally they may require shuffle, sorting, partitioning, state tracking, and row preservation, and also memory buffer, especially when we use the order by is used inside when you use the order by inside windows sorting become very expensive. Now, final most important understanding is group by rows collapse and it shows the one output row per group, but window function it shows the original rows preserved and additional calculated column added. This is the real purpose of window functions. Now let's see the what is this window specification. Till now, we already understood why window function exists and why group by collapse rows and why window functions preserve rows. Now, let's understand the window specification because internally, window execution completely depends on these window functions and inside that like the partition by, then the order by and also rows between. We'll see that. And these directly affect, just a minute. Hello. हाँ बिकॉज क्लास लो शिकौन हाँ हाँ ହୁଁ। ହଁ ସେଟା ଲଗେଇକି ତାର ଟିକେ ଛାଡ଼ିଦବୁ 15-20 ମିନିଟ୍ ସେ ତାର ସେଟା ଲାଗିଯିବ ପୁରା ତାପରେ ତାକୁ ଇଏ କରିବୁ। ହଁ ନା ନା ସେମିତି ଦରକାର ନାହିଁ ଜଷ୍ଟ ଟିକେ ହଁ ସେଟା ଲାଗିବ। ଆମେ ପରେ ଦେଖୁଛି ତୁ କରେ ଏ କ୍ଲାସ୍ ଚାଲିଛି ମୁଁ କ୍ଲାସ୍ ନଉଛି ଓଲଟା। Okay, and window execution completely depends on execution completely depends on partition by then sorry order by and the rows between. We'll see all one by one. And these also directly affect shuffle, sorting, memory uses, and also the execution cost and DAG complexity. Now let's see one by one. This is a small data set. We'll take this one. See, now We'll create this data frame. Now let's understand the partition by first. Partition by. So when we write like window specification window dot partition by department. Now internally what happened? Spark says bring same department rows together. When you use the partition by, in that window, Spark says bring same department rows together. So it will like bring all IT rows together and all HR rows together and all finance rows together. So when we run call a partition, this will happen internally. Now understand this. Initially, rows may exist in different partitions. As we know, all rows are not present in one single partition. In real time, it will present all department like the IT department. Suppose for the Rahul IT department, it will present in the partition 1, and Priya IT department, it will present in the partition 5, or like that. So now Spark must regroup rows, meaning again the shuffle happens. Now again exchange operator appears, new stage created, and shuffle write starts, and then shuffle read starts. Now the DAG usually becomes, when you call it partition by, the DAG becomes, it will first scan the data, then exchange. Now window, in window it will apply them. This happen internet. The DAG flow means the same department rows are being regrouped. Now after shuffle, internally Spark creates something like inside partition 0. Suppose include the all IT rows, and in partition 1 it include the all HR rows and finance. In partition 2, it will bring the all finance rows. This become the partition wise processing. Partition wise processing. This become the partition wise processing. Now let's see what order by do here. This is very important. Suppose we create window function, window specification like this. This is the suppose 1, and suppose we create another window specification like window specification 2, window dot partition by department. Then we also want the order by on salary, because we want to also sort the rows. So use the order by. Now Spark must do two things internally. In step 1, when you use this one, so in step 1, it will do like the bring same department rows together, and meaning shuffle. And in step 2, sort rows inside each department, and meaning sort operation. So when we call partition by and order by, this will happen. This will happen. Now, internally, IT partitions become something like, in IT partitions, it is like Rahul 50,000 and Priya 60,000 and Kiran 70,000. So internally, from this data, it will bring all the IT department into partition 0, and rows become order. See, here it is like 50,000, 60,000, 70,000, because this is also in order. So if the data is like this, suppose first 50,000 and 70,000, then 60,000. Then when we use the partition by and the order by, it will order the data like this. First it will bring the 50,000, then 60,000, then 70,000. It will sort the data in ascending order, because by default when you use the order by, it will sort the data in the ascending order. And if we want to sort the data in descending, we will use like dot descend. This will sort the data in descending order. Now, window functions with order by are much more expensive, because now Spark must shuffle row, sort row, and also maintain row order. These are three operations: shuffling happen, sorting happen, and also it maintain the row order. So sorting itself is the most expensive operation in Spark. Now the tag like, it will first scan the data, then exchange, then sort the data, then apply in the window. This is the DAG flow. Now look carefully. Before only exchange exists, now sort operator also appear, because Spark must maintain row order. After exchange, it will sort, then apply the window. So in this part, it will Spark also maintain the row order. Now understand why sorting is expensive. Suppose suppose one partitions contain partition 0 contain, suppose, 10 million rows. Now Spark must compare rows, rearrange rows, and maintain sorted sequence. These consume huge CPU and huge memory, and also this spill happen if the data is huge, because this is 10 million of rows. Suppose the size is like 500 GB or 1 TB, so it will also spill the data into the disk. Now, one important production concept is, if partition size become huge, then it will like memory full. First, it will write the data into memory, and after the memory full, it will spill sorted data to disk. This. And this is why order by inside window function is expensive. Now, let's see the rows between. This is order by. Now let's see the rows between. So now suppose we will create another window specification, like first we perform the partition by, then order by, then we perform another is rows between -1 to 1. Now, what does this mean? It means previous row, current row, and next row. These become the window frame. Like here you can see, this is the start and end. This is the previous row and next row. Now, suppose sorted IT rows are look like 500, sorry, 50,000 like this. Suppose the sorted IT department values are look like this. Now, for the 60,000 data, 60,000 row, window frame becomes like 50,000, then 60,000, then 70,000. Means this 50,000 is the previous row and the 70,000 in the next row inside the window frame. When we apply the rows between -1 and 1, and rows between -1 and 1 means one previous rows, then the current rows, then one next rows. Now internally Spark must maintain frame boundaries for each rows, meaning Spark continuously track previous rows, current row, and next row. This increases also memory use and state management complexity. Now, suppose we use like uh, if we use something like in SQL, window dot unbounded preceding, and then window dot current row. So now Spark create a running window, meaning for row one, uh, it will take the row one, this one, and for the row two, it will take the row one plus row two, like this. This is a complex one. For this, when we use this one, rows between when we use these, it will like for row one, which is the suppose Rahul. For this, it is only row one because there is no previous rows. But for row two, which is the Kiran, this will become the row one plus row two because there is a previous row one, row two. Now for the row three also, row three is the here. This will become the row one plus row two plus row three, like that. This flow will happen when we use the row between, and imagine how much complexity is this. Now this process continuously maintained by the Spark internally when we use the window functions. So that's why this is the most expensive one than the group by. Now internally Spark processes sequentially something like uh, current row, current total equal to previous total plus current value, this one. This one. Now, Spark maintains state in memory during execution. Now, very important thing is window execution is not random. Spark processes partition wise and ordered sequence wise, also frame wise. That is why internally windows are expensive. Now let's see the specification together. Suppose we use this one in the specification 5. Let's use this in a real example. Now internally, Spark does like in step one, it will shuffle rows by department first, shuffle rows in department by using the partition by. Then in step two, it will sort the rows by salary inside department. First, it will bring the all department. Then inside that department, it will then sort the rows. Then after that, it will create a window frame by using the rows between and then apply calculation row by row. So the final DAG becomes scan, exchange, then sort, then window, frame, processing, then window calculation. This will happen internally when we use a window function. But first is to scan the data, then it will exchange, then sort the data, then create a window frame processing. Then after that, it will apply the window calculation. And this is actually window specification execution internally. Now, another important production understanding is window functions become expensive because they combine shuffle, sorting, frame tracking, state management, memory buffer, and also display. Especially when a partition is huge and when there is a skewed key, and also in some case like a large order by operation can become very slow. So in production, we we will carefully use the order by, because that is sorting is the very expensive thing. So this is the whole flow internally when we use the window functions. Okay, now suppose let's apply this first. This is the last one. Suppose we want uh, um, suppose we want to see the salaries by row number. So for that, we just use this simple one, this is, and then apply like df dot with column, then the row number, then we use the row number function, then over and pass the window specification dot so. Now let's start this. See, this is the picture. When you see this, what happens? Internally, first it bring all department all department, then sort inside department. This department 7. Then apply the row number on that window. This one. So internally, the process is like this. First, it bring the all department, then sort those department according to salary wise, then apply the row number into the each row on that window frame. This happen internally. Okay. ଆଉ ବାକି ରୋ ନମ୍ବର ଡେନ୍ସ rank ଆଉ ଲିଡ୍ ଲ୍ୟାକ୍ ଏସବୁ ଫଙ୍କସନ୍ ନେକ୍ସଟ ଦେଖିବା ନା କ'ଣ କହୁଛୁ? ହ୍ୟାଲୋ, ଶୁଭାଯାଉନି କିଛି।
ର୍ୟାଙ୍କରେ ବି ନର୍ମାଲ ଯେମିତି 1 2 3 କହିଲେ
ହଁ, ଯେମିତି ଯଦି SQL ରେ ତମେ ୟୁଜ୍ କରିଛ ଯେମିତି କି rank ରୋ ନମ୍ବର ଡେନ୍ସ rank ଆଣ୍ଡ rank ସେମ୍ ଟାଇପ ର ହିଁ ଏଥିରେ ହବ। ବାକି ଆମେ ଖାଲି ଦେଖିବାର ଅଛି କେମିତି କ'ଣ ତାର ସିଣ୍ଟାକ୍ସ ରହୁଛି ଆଉ ସେଟା ନେକ୍ସଟ କ୍ଲାସରେ ଦେଖିଦେବା ଆଉ।
ହଉ
ଠିକ ଅଛି,
ଠିକ ଅଛି,
ବଢିଆ
ଠିକ
ଥିଲା
ଅଛି।
ଭାଇ ସେସନ, ଥ୍ୟାଙ୍କ ୟୁ।
ହଉ।
କିନ୍ତୁ